We'll continue our series, Our Place in the Universe, with a look at our galactic neighborhood. We've learned that a planet orbits a star, and we call that a solar system, but many solar systems together form what we call a galaxy. In our case, if this were our solar system here, if that were our sun would be approximately at this location. The plane of our orbit is at an angle with respect to the plane of the Milky Way, and the sun takes about 250 million years to orbit the core of our galaxy. But our Milky Way galaxy has neighbors. And we'll first start off with these two clusters of stars called the Small and Large Magellanic Clouds. They are seen in a picture like this. This was taken in the country of Chile in South America, and you can only see these Magellanic Clouds from the southern hemisphere. So here's the small, and here's the large. The large and small Magellanic Clouds are about 150,000 to 200,000 light years away. The small one has about 3 billion stars, while the large has around 30 billion stars. So it would take 150 to 200,000 years for light to travel from Earth to these celestial objects, these clusters of stars. It would be sort of these are small galaxies. Through the Hubble Space Telescope, we can see a close-up view in the Large Magellanic Cloud. There are lots of new stars forming in this region. And again, work from this telescope system in Chile, the ALMA telescopes, detecting microwave and radio wave emissions. They have detected, in the Large Magellanic Cloud, they have detected the signatures of molecules, organic molecules, molecules with carbon. And so again, if molecules are out there in deep space, it seems that chemistry is going on all over the universe. And that is part of an important story for how life can emerge in the universe. Here's another image in Chile in the high desert. Here we see the Milky Way. This is a panorama, so the Milky Way appears curved, the way the stitching software makes the picture. And down here, the bottom right, we see the Large and Small Magellanic Clouds. Here's another shot outside of San Pedro de Atacama in Chile. This time the Magellanic Clouds are over to the left here. Now, in a diagram like this, here's our Milky Way. The Magellanic Clouds are these two little small spots right there. We'll highlight them there. But there are larger neighbors that we have, but just more distant. And that larger neighbor is the Andromeda Galaxy. So the dimension here, the scale here, is 4 million light years from here to here. The Andromeda Galaxy is about 2.5 million light years away from the Milky Way. So here's the Andromeda Galaxy. Now to find the Andromeda Galaxy, you can find Cassiopeia, a constellation in the night sky, and it kind of makes this sort of W-type shape, and that the pointy part of this part of the Cassiopeia constellation kind of points to Andromeda. In Joshua Tree, the little fuzzy patch right here is the Andromeda Galaxy. If we can crop in, it is a little fuzzy thing. You can't see it with the naked eye, but you need dark skies. A wide-angle camera would give you a picture like this, but if you have a longer lens, you'll get pictures like this. Now we can start to see some of the structure of the Andromeda Galaxy. We've got dust lanes here. So this would be regions of gas and dust that are opaque to light. There is a small little satellite galaxy around Andromeda, just like the Milky Way has the Large and Small Magellanic Clouds. The Andromeda Galaxy has a nearby galaxy as well. Here we have more color in this image, again showing some of the detail, the dust lanes in the disk of Andromeda. Another kind of image, and yet another image. In this kind of image, using editing techniques, the stars have been reduced in their size, so it appears like we're just sort of looking at the Andromeda Galaxy after we've removed ourselves from our own galaxy. Now this is an image of Andromeda from the Hubble Space Telescope, and here we see the core over here on the left, and then as we move out we have the outer parts of the galaxy. Now we'll center it here, and then we're going to zoom in, and we're going to see that the Andromeda Galaxy is composed of hundreds of billions of stars. We can see the dark regions here would be the opaque areas of dust and gas, and then some of these areas up here where we see these blue stars, these would be star forming regions. So where new stars are burning big and bright. Here we have another area over here, here and here and here as well. Some of the big stars with the diffraction spikes, they would be stars in our own Milky Way galaxy. This one, etc. Now, the Andromeda is a large galaxy. In the night sky, we just see the core of the galaxy. If we could see the entire extent of the galaxy with our eyes from Earth, it would be about 6 times the diameter of the moon in the night sky. It's a large structure, but we only see the brightest part of the galaxy, the core. This image was sort of created through Photoshop to show the relative extent of Andromeda. If we could see the entire galaxy, it would look like this in the night sky, about 6 times the diameter of the moon. We just can't see the faint regions of the outer disks of the galaxy. Now, Andromeda is 2.5 million light years away, so it would take light 2.5 million years to get from Milky Way to the Andromeda. The Andromeda Galaxy is larger than the Milky Way, 140,000 light years wide to the 100,000 for the Milky Way. But interestingly, the two galaxies appear to be in relative motion towards each other. Now, we'll learn later, from our point of view, most galaxies in the universe are moving away from us. But there are some exceptions to this. Some of the nearby galaxies are moving towards us. So the mutual gravitation of the two galaxies is causing relative motion towards each other. In fact, in several billion years, scientists predict the two galaxies will collide. Prior to that moment, the Andromeda Galaxy will get bigger and bigger in our night sky. So this is just a Photoshop of some of the pictures I've taken. So here is our Milky Way off the coast of California, Pacific Ocean. Here's the moon, and here is the Andromeda Galaxy. And as our galaxy gets closer and closer to the Andromeda Galaxy, or it gets closer to ours, however you want to look at it, we're going to see the Andromeda looming in the night sky. Hubble has taken pictures of this kind of event, galaxies colliding. Here's another one. It's a big mess. Now, scientists don't think that the stars will actually hit each other. There's so much space in between stars. But there will be a gravitational disturbance as the two galaxies collide. And here's an animation showing what that can look like. So here we have the Milky Way galaxy. Andromeda, and again, the mutual gravitation between these galaxies is causing relative motion towards each other. In some 4 billion years, they will collide. The result is predicted to be a larger, sort of elliptical galaxy. Now, the merging of galaxies is thought to be a common occurrence, or it was more common in the past. Scientists think galaxies in the early universe were the size more of the Magellanic Clouds. So lots of small galaxies can merge to make larger galaxies. And as we're seeing here in these photos here, even large galaxies can merge with other large galaxies. So at this point, we're ready to concede that we live in a huge universe. Our entire galaxy is just one of several in our local neighborhood. In the next and final lesson, we'll learn that our universe has hundreds of billions of galaxies in it.